Hello, ladies and gentlemen. Welcome to Physics 20, Kinematics Lesson 4, Acceleration Calculations. Now, today we're going to derive some equations for you. Now, I want to say this right off the bat. I do not expect you to memorize how we derive these equations or where they come from. The idea behind this is to show you this isn't magic. Oh, there's logic and reasoning. I can figure this out. But you also have the formula sheet, so you don't have to figure it out. You have the formulas. I'm just showing you where they come from. Now, first things first, here's a velocity versus time graph. You start at v initial, you're into v final. Okay? Now, that is a straight line, y equals mx plus b, math 10c. Your y, or your final value, is your v final. Your slope is a, acceleration. Your x is time, and v initial is your b value. Okay? Now, that is written on your formula sheet, v final equals v initial plus at. That is the first formula you have to be able to use. Notice I'm not saying know and use, but you have to be able to use it. So you grab your formula sheet and you go, put your finger on it, velocity final equals velocity initial plus at. Oh, once again, I apologize. I am supposed to be using those little vector arrows above, and I keep forgetting. I apologize. All right? So that's the first formula we have to know. And they use a slightly fancier font on the formula sheet, whatever. All right, so far so good? Good. Now, I'll come back to this, the other bits in a minute. I want to use this in equation in question while it's still fresh in your mind. Bill pulls out of the school parking lot at 5 meters a second, and he accelerates at 1.5 meters a second for 4 seconds. What's his final velocity? Now, first thing we have to do is read the question, highlight or underline the important stuff. Accelerates 4 seconds. Parking lot, pulls out. Okay, now, second draw picture. There he is, pulling out of the parking lot. That's my picture. Third thing, make a list of everything you know. Now, he pulls out of the parking lot at 5 meters a second. That's v initial. We don't know his v final. That's what we're asked to find. What is his acceleration? 1.5 meters per second squared. We don't know his displacement, but we do know the time is 4 seconds. So displacement, acceleration, v final, v initial. All right. Now, what is his final velocity? Well, what's the formula we need? Velocity final equals velocity initial plus at. It's the only formula we have. Well, it's not the only one, but it's the only one we've used so far. So this is 5.0 meters per second. And its acceleration is 1.5 meters per second squared for 4.0 seconds. So 1.5 times 4 is 6.0 meters per second. So his final velocity should be 11 meters a second. 1.5 times 4 is 6. 6 plus 5 is 11. Yes. So, okay. Now notice we haven't solved for his displacement yet. We'll get to that. Now, going back, there's a couple things I want to point out here. First, we can rearrange this equation. Velocity final minus velocity initial equals at. Or we get a new formula for acceleration, which is change in velocity over change in time. Well, actually, it's not the new formula. It's one we've seen before. Right? The other thing that we'll use, the other thing I want to point out is the displacement is the area under the graph. Now, if you think about it for a sec, we could find v average. Velocity average is the average of your velocities. It's v final plus v initial divided by 2. So I will ask questions, what's the average velocity? Notice I haven't yet, but I could. And I could ask, what's his average velocity here? The average, v final plus v initial divided by 2 is 11 meters a second plus 5 meters a second, which is 16 meters a second. 2. So v average is 8 meters a second. Right? Now, that's as an aside. You will have to do those calculations on your own. But something straightforward like that, I think you can get yourself. Or you can figure out yourself. Moving on, here's another formula. Well, I'm deriving another formula for you. Area under the curve, or under the graph, under the line, is displacement. So, this triangle up here, triangle, formula area is 1/2 base times height, or in this instance, 1/2 time times v final minus v initial. Okay? But we just said v final minus v initial is AT. We did that the first page with the calculations. So instead of v final minus v initial, I can replace it with AT. So that triangle up above is 1/2 AT squared. You don't have to memorize it, but note here, displacement, sorry, the triangle down below, or the triangle, forgive me, ladies and gentlemen, the rectangle down below is velocity initial times time. So now we have two formulas. Actually, we have one formula. Displacement is v initial t plus 1/2 AT squared. All right? So I just derived that for you. I'm not going to derive it for you, but I want you to realize, oh, this triangle here is 1/2 AT squared. So I can do v final t minus 1/2 AT squared. Now we've got two more formulas you can use. So notice they're both on your formula sheet. Displacement v initial t plus 1/2 AT squared. I'm looking at my version of the formula sheet, and and this little divisor sign didn't show up very well. But it is there. So here's two different versions of the formula we can use to find displacement. And I have a question. How far did he travel? Now, be careful. This is part B, which means we have to look back at part A for the information. I'm just too lazy to write it out again. So here we go. V initial, V final, acceleration, displacement, time. We have V initial, we have V final, we have acceleration, we have time. So he started at 5.0 meters per second. He ended at 11.0 meters per second. His acceleration was 1.5 meters per second squared, and his time was 6 seconds. Just double checking because I'm old. Come on, you poopy head. Oh, 4 seconds. Never mind. All right. Okay. So, what formula do we use? Oh, I didn't bother drawing a picture because I drew it in the last question. I should go, there he is driving. So, displacement is v initial t plus 1/2 AT squared, or displacement, vector, 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 v final t, sorry, minus 1/2 AT squared. Does it matter which one we use? No. I was only taught this first one, the plus one, at university. I was never taught the second one. So you'll find I don't use it very often, and I should use it more. So I am going to use the second one here. The displacement is v final, 11.0 meters per second, times time, minus 1/2 the acceleration, meters per second squared, and 4 seconds. Okay, so the displacement, or how far Bill traveled. Now, here we need a calculator. 11 times 4 is 44 meters. You can try that. 4 squared is 16, half of 16 is 8. That should be 12, I think. Let me double check. 0.5 times 1.5 times 4 squared. It is 12. Woohoo! I do have that many fingers and toes. Displacement is 32 meters. Notice it's plus 32 meters. Okay? Now, if you don't believe me, try it using the first formula, v initial t plus 1/2 AT squared. It should still work. All right? Now I'm going to pause there. I want you to review this, and then we're going to go on to my first favorite trick. Any questions, shoot me an email. Otherwise, good luck.